Hey Algebra folks. So in our last video for our day 1 review, we were covering how to do some basic polynomial operations. So that included combining like terms, multiplying using either FOIL or the box method, and finally division, but really just division of a polynomial with a monomial. So an expression with a lot of terms divided by an expression with only one term. And so over here, we're going to be talking about what we spent the majority of trimester 2 marking period 2 talking about, which is factoring, right? And when we were covering how to multiply polynomials together, we described it as the opposite of factoring. So when we're talking about factoring, we're talking about undoing or doing the opposite of multiplying. And this is really multiplication of polynomials. Okay? This is such a key concept in Algebra 1, and it really helps us understand some characteristics of functions a little bit better if we know how to factor, so we can create different equivalent expressions. So let's actually go into some of the factoring methods that we learned about, just so that we can review and we're all on the same page. So before we even get started with talking about factoring, we want to just refresh ourselves on what an expression actually is, what the definition of an expression is, right? And so whenever we see this word expression, it's really when you string variables and numbers, or a combination of variables and numbers together. And most oftentimes in our expressions, we have something called a coefficient, right? So coefficient is something like this 5 over here that's hanging out or being multiplied to this variable over here. And then whenever we just see a regular number just hanging out on its own, it doesn't have a buddy with a variable or anything next to it, we call that a constant, right? And that's going to be really important that we know how to identify parts of an expression, especially when we go into representing expressions as functions, okay? So whenever we have a lot of terms, right? Whenever we have a lot of terms, that means that we have a polynomial expression. This prefix poly actually means many, right? So whenever you see the word poly associated with something, that means that there's a lot of whatever that something is, okay? So in trimester 2, specifically marking period 2, we learned that we can simplify expressions by factoring. And so we covered a lot of different methods, right? Our first one, it's our go-to, is going to be greatest common factor factoring. We call that GCF just so that we don't have to keep saying greatest common factor over and over again. And then we built off of that and did something called factoring by grouping, which requires us to use this GCF factoring skill. Then we went into X method, and then we did the AC method for when our A is not equal to 1. Our X method was for when our A equal to 1 in a quadratic. And this AC method is our modified X method. So it's very, very similar. Okay. And then finally, we went into the special case towards the end of the marking period called difference of squares factoring, right? And difference of squares factoring is very, very simple if you know what your perfect squares are and if you are very proficient in your X method factoring, right? So before we can get into that special kind of factoring, we want to make sure that we're super solid on everything above. And all of the methods, right, as you're going down the list, they actually rely on the factoring method that you covered before, right? So if you're struggling with something like greatest common factor factoring, right, it's going to be a little bit difficult to actually be successful with X method and AC method factoring unless you're super solid on this method here. So make sure that before you even move forward that you're really good with GCF factoring, because it is kind of like the backbone of all the other factoring that we do. All right, so let's go through some examples, right? Over here, you know, I tried to label it. Might look a little bit chaotic, so I just want to walk through it with you, okay? So when we're talking about greatest common factor factoring, we want to first find out what our greatest common factor is, right? And the easiest way for us to find out our greatest common factor is to break it down, right? So the first thing that we want to find our GCF for is our coefficients, right? And coefficients, as we said before, are those numbers like 12, and 16 that are hanging out in front of your variables, right? And so when I find the GCF of my coefficients, I want to actually list out the factors of my coefficients. So my factors for 12 are 1, 2, 3, 4, 6, and 12. My factors for 16 are 1, 2, 4, 8, and 16. I like to write these out in going from smallest to largest, just so that I can more clearly see whether or not any of these values overlap, right? And if I look closely at this, right, I see that 1 is a common factor, 2 is a common factor, and 4 is a common factor. And that's about it, right? And because 4 is the largest common factor I have between these two values, I know that 4 is going to be my GCF, okay? So 4 is my GCF for my coefficient. Let's actually move on to my variables now, right? So my variables are going to be n to the 5th power and n to the 3rd power, right? I see that I have the same variable n in it, right? If they're not the same letter, then you don't have a GCF for your variables, but because we do have the same letter variable, I know that I do have a GCF for these variables. So I want to just write out both of those terms, right? I have n to the 5th power and n to the 3rd power. And whatever my variable is with the lower exponent is going to be my GCF. So because n to the 3rd power has a lower exponent, that's going to be my GCF, okay? So then step 3 is just to combine what I learned in step 1 and 2 to create my big GCF, which is going to be 4n to the 3rd power, right? I just literally smushed those two together. I actually multiplied them together, okay? So let's go on to step 4, right? What do we do with this big GCF now, right? So the reason why we find this big GCF is so that we can actually divide it out from each of our terms to figure out what that factored expression is going to be. So I take my original expression, 12n to the 5th power, going to divide it by my big GCF over here, right? 16n to the 3rd power divided by my big GCF over here, right? And when I think back to my first day when I was dividing polynomials by monomials, I remember that I want to first divide out whatever my numbers are first. So my first thing that I'm going to divide out is 12 divided by 4, right? I want to divide out the coefficients, and that's how I get this 3. For n to the 5th power and n to the 3rd power, right, my variables, I really want to subtract my exponents to figure out what my new exponent would be, right? So I know that my n, my variable, stays the same because there's only one letter going on there, right? And then I just subtract my exponents, so I do 5 minus 3, and that's how I get this value of 2, right? Let's move on to the next term, right? So once again, I want to first divide out my coefficients. So I do 16 divided by 4, which is how I get that value of 4 over there. For my variables, right, I have n to the 3rd power divided by n to the 3rd power. When I do 3 minus 3, when I subtract those exponents, I get 0. Anything raised to the 0th power is 1. So I'm actually not going to write my n there. I don't have any more n's left, so I'm just going to keep it as a constant of 4, right? And now I want to assemble it all together, right? So my structure for this is really going to look like this, right? My structure for this is I'm going to put my big GCF, right, on the outside of my parentheses, okay? And then I'm going to open up a parentheses, and what goes inside is whatever this factored expression is that I got in step 4. Okay? So when you're using GCF factoring, it's really to create something that's a little bit more manageable to deal with, because usually whenever we take out the GCF, we're dealing with much smaller numbers that are a little bit simpler and easy to deal with. So let's make sure that we actually understood what we were doing when we were doing GCF factoring. So take a minute to just pause here, work through this problem, right? I actually created a guided step-by-step way of dealing with this, so you can use that as a framework for you, right? But if you feel like you're super confident in this, go ahead, right? I recommend that you pause this video here and just work through this problem before moving on, so that I can actually review it. All right, you did the problem. Let's check if you're right. Okay, so the question is saying factor the polynomial by its greatest common monomial factor, right? So I want to give a factored expression for my answer, right? I don't just want to give my GCF. So before I go ahead and give the factored expression, I need to go and find the GCF for my coefficients, right? And when I look at my expression, right, my first coefficient is going to be this 44 that I see here. Then I have this negative 66, and then finally 77. Okay, so using this information, let me just write out what I know, right? I have 44, whoops, 44, I'll write that a little bit thicker, right, okay, so I have 44, and then I have 66, negative 66, and then 77. I'm not going to really worry about this negative for the time being. I'm just going to think about what are my factors, right, just so I can find my GCF. So when I think about the factors of 44, right, I want to think like 1 and 44. I always know 1 and the number itself are going to be my factors. 2 definitely goes into 44. 2 times 22 is 44. And then I know that 4 times 11 is going to give me 44 because I know that trick about multiplying by 11, it's going to give me the number twice, right? Same thing with negative 66. 1 and 66 are definitely factors. 2 is definitely a factor with 33, right? 3 is definitely a factor with 22. And then I also know that 6 and 11 are also going to be factors. Okay? And then finally with 77, 1, 77. And then I also know that 7 times 11 is also going to be a common factor. Right? So I just want to evaluate what are my common numbers that are showing up in these lists, right? So my common number is 1, and then I also have a common number of 11. And that's really it, right? And so because 11 is the largest number out of those 3 lists, my GCF is going to be 11 for my coefficients. Okay, so I figured out the GCF for my coefficients. Now let's actually look at my GCF for my variables, right? And I think I colored that green last time, so let me just keep consistent with that. So my first variable that I see here is k to the 5th power, and I see another k variable here, but it's k to the 4th power this time. And once again, we have this variable k over here, but it's raised to the 3rd power that time, right? So those are my 3 variables, so let me just write that down over here. I have k to the 5th power, k to the 4th power, and k to the 3rd power. Right? And I remember that whenever I'm finding the GCF of my variables, as long as they're all the same letter, right, I want to pick the lowest exponent, right? And so the variable with the lowest exponent is k to the 3rd power, so my GCF is just going to be k to the 3rd power. And now, for step 3, I want to get my big GCF by just smushing together my GCF from step 1, which was 11, right? And swishing together my GCF from step 2, which was k to the 3rd power. And that's going to be my big GCF, right? So let's use that big GCF, right? We're going to use that big GCF to divide out every single term in my expression. So underneath every single term in my original expression, I'm going to write this in yellow because that's going to represent my big GCF. 11k to the 3rd power, 11k to the 3rd power, 11k to the 3rd power, right? I'm going to use my dividing skills for polynomials and monomials in order to actually divide this out, right? So when I do this, I get 44 divided by 11 is 4. K to the 5th power divided by k to the 3rd power is the same as having 5 k's, taking 3 k's away, and you're left with 2 k's, right? Negative 66 divided by 11, going to divide my coefficients first to get negative 6. K to the 4th power, k to the 3rd power, right? It's the same as having 4 k's, take away 3 k's, you're left with 1 k, right? So k to the 1st power, or you could have just written k, that's also fine. Next term, positive 77 k to the 3rd power divided by 11 k to the 3rd power. First, divide out your coefficients. So 77 divided by 11, that gives me 7, right? 3 k's, take away 3 k's, you're left with 0 k's, right? So I'm not going to write any k's next to my 7 over there, right? So I just want to assemble this all together, right? I know that my big GCF, right? My big GCF was 11k to the 3rd power, right? And now I want to take this expression that I worked really hard on creating, right? This value right over here, and just write it over here, right? So it's 4k squared minus 6k plus 7. And that is my fully factored expression. Okay. If you're having trouble understanding this, make sure that you're pausing here, going back to the original example. And if you're still struggling to understand, how I did the example, how I did the check for understanding, pause right over here, annotate this question, and make sure that you're asking me this question during office hours so that maybe I can explain it in a slightly different way. Okay, so we finished the first method of factoring. That is the backbone of factoring, GCF factoring, right? Now I want to take it to the next level and try something called factoring by grouping, right? So for factoring by grouping, right, we want to first split our expression in half to create two groups, right? And so when I look over here, I see I can split my expression in half by taking this as the first group, right? And then my second expression is going to be this group right here. Okay, so I have group 1, and group 2. Okay, now this is why I'm saying that factoring, GCF factoring is so useful, right? Is with each of these groups that you just created, just take out the GCF. So imagine it as one problem at a time, right? So let's actually focus on the first group that we created, right? When I take out the GCF of my first group, right, I notice that my GCF is going to be 8r squared. And so I'm going to divide out each of my terms by 8r squared to get 5r minus 1, right? And so that's going to be my first GCF factor group. Take a minute to actually just take out the GCF of your second group, right? Your second group is right over here, right? And then when you actually do that, you should end up getting negative 5 times 5r minus 1, right? The reason why I took out a negative 5 instead of a positive 5 is because your final goal is to end up with a common group, right? And when we look at these two factored groups, we see that we have 5r minus 1. Whoops, I write that in a little bit more opaque. We have 5r minus 1. And over here we have 5r minus 1 again, right? And so when I have that common group, I can actually go ahead and do my factoring by grouping. So I'm going to take out my my common group, right, which is 5r minus 1. I'm going to place them in one parentheses right over here. So let me just do that in yellow, right? This is my common group. And everything that's left from my original expression, right? So this is the negative 5, and this is the 8r squared, right? I'm going to place in a second group of parentheses. And then this is going to be my fully factored expression, right? Now we could maybe try to factor this 8r squared minus 5, but that's not really what we're focusing on right now, right? We're going to be just focusing on factoring by grouping, making sure that we're factoring out the GCF, and then finding a common group. Let's actually check that we understood exactly how to do factoring by grouping. So I really recommend that you pause right over here for a couple minutes and just work through the problem. Once again, I listed out step by step what you're trying to do. So every single line that has that's blank, you should be filling out with something, right? But really just go through the steps. If you're having trouble doing this, check for understanding. Make a note of this so that you can ask me during our Google Voice or Zoom conversation. All right, so pause here. All right, you worked through the problem? Did it okay? Let's actually check that we did it correctly, okay? So the question's asking us to factor the following by grouping, right? So the first thing that we want to do is just split our expression in half to create two groups, right? So I'm just going to take the first two terms that I see over here. I'm going to make that one group, right? So these are the first two terms I see, and the second two terms I see are right over here. So my first group is going to be, let's see. My first group is going to be 35 x to the third power minus 10x to the second power. And then my second group is going to be negative 56x plus 16. Okay? So with these two groups, right, I want to go ahead and try my GCF factoring skills, right? And so when I look at 35x to the third power minus 10x squared, I know that my big GCF, I know that a number, the biggest number that goes into both of these is going to be 5. So let me actually just write that, right? It's going to be 5, right? And then I have an x cubed and x squared in both of my terms, right? So I have a common letter, right, but different exponents, and I want to just pick the exponent that's smaller, so I'm going to pick x squared. That's going to be my big GCF. Right, so I take that big GCF and I'm going to divide each of my terms in group 1 by that big GCF. So I'm going to write 5x squared parentheses, And what goes inside is that divided out expression when I divide out my big GCF. So 35x to the third power divided by 5x squared. So 35 divided by 5 is 7. X to the third power divided by x squared is going to be 3x's, take away 2x's, you're left with 1x, right? I don't have to write that 1 there, but just for clarity's sake, I am. Negative 10x squared divided by 5x squared, right? So negative 10 divided by 5 is negative 2, right? 2x's, take away 2x's, there are 0 x's left, so I'm not going to write any x's over there, right? So this is my fully factored group 1 using my GCF method. My fully factored group 2 using my GCF method, once again, requires me to look and see what's actually going to be my GCF. And when I look at my coefficients, negative 56 and 16, I know that my GCF for those terms are going to be, I believe it's 8, right? But I'm going to take out the negative 8, okay? And you'll see why in just a second, right? So if I take out a negative 8, and I don't have a common variable in both of those terms, my big GCF is just negative 8. Going to divide out that entire expression by negative 8, so I have negative 8 parentheses, right? And so when I do negative 56x divided by negative 8, I end up with a positive 7x to the first power, right? Because a negative divided by negative gives me a positive. And I'm already starting to see that my common group is going to be 7x minus 2, right? Because negative 56 divided by negative 8 gives me 7x, and then 35x to the third divided by 5x squared gave me 7x as well, right? So I want to make sure that I'm coming up with a common group. If everything's the same except for the signs, you have to take out a negative, right? Let's try the next one, right? So 16 divided by negative 8 is going to give me negative 2, right? I think I see my common group, right? My common group is going to be this 7x minus 2, 7x minus 2, right? So I'm just going to write that out, right? I have 7x minus 2, okay? That's my common group, right? What's left, right? I see that I have a 5x squared here and a minus 8 over here. So I'm just going to write that in a separate group of parentheses, right? So I have 5x squared minus 8. Oh, whoops. Let me just color code that. Minus 8. And that's going to be my fully factored expression because I don't really have any other terms left to deal with. Okay? If you're struggling with this, take a pause, make an annotation, right? Because this is going to be super useful when we do our AC method, which is coming after the one that after the X method that we're covering next. Okay. So before we go to our next method, I just want to review a few key parts about quadratics, right? We mainly deal with factoring when we're dealing with quadratics, just because we can find out a lot of key information about quadratics once we factor, right? So when we have a quadratic equation, right, this is our general form, ax squared plus bx plus c equals 0, right? And we have a few parts, right? So this a that we see over here, let me change it to be more of a purple color, right? So this a over here is our coefficient for our x squared, or whatever letter your variable is term, right? So it's always going to be a number, right? A, b, and c are always going to be numbers because they're coefficients, right? So it's whatever number is hanging out before your squared term, right? And then you have b, right? B is over here, and b is your coefficient for your x term. So it's whatever variable is raised to the first power. And if you don't have an x term, then your b is going to be 0, right? But if you do see a number there, then it's going to be whatever number is hanging out there, right? And then finally, we have this constant c, right? And remember, constants are just regular numbers. If we don't see a constant there, then our c is just 0, right? So this is going to be pretty important when we're going over our next few factoring methods. So let's look at this. We are dealing with the x method now, and we know that we can only use our x method when our a, right, when our a over here, let me turn that to purple, is equal to 1, right? If we have an expression where our a is not equal to 1, then we have to use the AC method, which we're going to cover next, right? So it's really important that we know how to identify what our a, b, and c are, just so that we can, one, figure out what method we can use, and 2, so that we can actually do some of these methods, right? So if our a equals 1, we can use the x method. Let's move on. In order to use the x method, our first step is to identify what our b, right? What our b, b and c are, right? And so our b over here is negative 15, and our c over here is 50, right? So I'm going to draw a giant X, and I'm going to place c at the top and b at the bottom. Remember, b for bottom. And I want to make sure that I'm watching my sign, right? So see how I noticed that this was negative 15 and not just 15? I carried the sign over because it's going to be really, really important in order to figure out our proper factor pair. So I do all this work, right? What am I supposed to do with that now, right? I already moved on to step 2 where I placed my c at the top, b at the bottom, right? Now what I want to do is actually find a factor pair of c that sums to b. And we want to write this factor pair on the sides of our x, right? So I want to multiply to 50, add up to negative 15. So I want to think about my factor pairs of 50, right? I know that I have 1 and 50, 2 and 25, 5, 10, negative 1, 50, and negative 50, negative 2, negative 25, and negative 5, negative 10, right? I'm including these negative values because I know that a negative times a negative is going to equal positive, and 50 is positive, right? So I want to account for all these possibilities. After I find my factor pairs, I actually want to add them to see if they would add up to my b value. And I'm seeing that none of them are adding up to my b value except for negative 5 and negative 10. Because when I add them, I get my b value of negative 15. Okay? So I know that because this multiplies to my c, my negative 5 times negative 10 multiplies to my positive 50, and adds up to my b value, negative 5 plus negative 10 is negative 15. This is going to be my factor pair. I'm going to write them on the sides of my x, just so I can visually see what's going on, right? Now that I found my factor pair, I literally just plug them into something called a skeleton, right? So my skeleton is generally going to look something like this. So parentheses, whatever your variable is, usually your variable is x, so I'm going to write x. Close parentheses, open up another parentheses, x, close parentheses, and I'm going to put my factor pair here and here, right? In this case, my factor pair was negative 5 and negative 10, and that matches exactly the expression that we've factored using the x method, okay? Your main goal, just multiply to c, add up to b, and make sure that you're watching your signs. So, we just covered the x method, right? What I want you to do is actually do a check for understanding. So just like how we did in the other examples, right? Pause here, see if you know how to do this. Use the structure that I've provided on this sheet in order to help you actually complete this problem. All right, you tried out the problem. You want to check to see if it's right? Let's go ahead and do it, right? So before I can even get started, I want to just make sure that I can actually use the x method, right? And so when I look at my a, b, and c, I see that my a over here, I don't have a value. I don't see a value next to my x squared, right? So I know that that secret value that's hiding is 1. So in this case, my a equals 1. So a equals 1, and I can move forward with my x method. Now I want to identify what my b and c are, and I want to make sure that I'm including my signs over here, right? So over here, I'm seeing that my b is negative 4. Right, I'm going to include that negative sign. And my c is going to be positive 24. So let me just write that down in my blanks, right? b is negative 4. c is positive 24. Right? So now, with my step 2, right, I want to actually place my c at the top. So 24 at the top. And then I want to place my b, my negative 4, at the bottom. Remember, b for bottom. Okay? So now that I've done that, I want to actually find my factor pairs of 24 because I want to multiply, right? I want to multiply to this value, right? So when I think about my factor pairs of 24, I can think of like maybe 1, 24, 2 and 12, 8 and 3, and 4 and 6. All right, and I'm noticing that I want to multiply to positive 24, right? So I know that I can multiply 2 positives together, but I can also multiply 2 negatives together. So what I'm just going to do on these bullets, right, I'm just going to change the sign for all these factor pairs that I already listed out. So -1, -24, -2, -12, -8, -3, and -4, and -6. Now with these factor pairs, I know that I actually want to add up what these factor pairs are and get my b value, which is -4. So when I do 1 plus 24, I get 25. I know that's not going to be my answer. Let's move on. 2 plus 12 gives me 14. Not my b value, going to move on. 8 plus 3 is 11, which is not my b value. 4 plus 6 is, what's it called? 10, right? Over here, I have -1 plus -24 is -25. Over here, I have -2 minus 12, or -2 plus -12 is -14. This is going to be -11, and then this is going to be -10. All right, you should see a problem going on, right? So when we look at all these sums, none of them are adding up to our b value that we decided was -4, right? And so if we can't find a factor pair of 24 that adds up to -4, we can't find a factor pair of our c that adds up to our b, right? That means that we don't have a factorable solution, right? So we can't actually go ahead and write this. So let me just write that out, right? Let me do some blue, right? So there's no factor, right? And then we can't use the structure because it's not factorable. So we would just say not factorable. Now, if I wanted to change this so that it would be factorable, so like let's say that you're taking the regions and they said, what value of b could you give so that your function, your quadratic, can be factorable, right? You could have given any of these b values that we listed over here, right? So if you gave any of these values, if you change your b to any of those values, then it would have created a factorable quadratic, right? But because that's not what our b value was, and our b value was -4, we do not have a factorable solution, so our answer should be not factorable. If you were really frustrated with this problem, that is fine, right? It didn't look like our example, right? But then it's meant to keep you thinking about what does it mean to actually find a factor pair that works and to actually have a factorable expression, right? So if you're struggling with this, don't worry about it. There are going to be plenty of examples in your practice problems, and you can look back in your notes from trimester 2 to help you with this too. But look out for those examples where your expression is not factorable. Okay, so we covered the X method, right? What we want to do now is cover something called the AC method, right? I wrote this all out because I don't really want to put you through my horrible handwriting, but let's actually go through what I wrote out because it's a little bit confusing, right? So let's look at the first example. I'm given 2x squared plus 7x plus 3, right? My first step is always just to check to make sure if I have a GCF or not, right? Like I said before, GCF is like the backbone of all our factoring methods. So let's make sure that we actually look for a GCF, right? And so when I look at 2x squared plus 7x plus 3, 2, 7, and 3, they don't have a common factor other than 1, so there's no GCF. There's an x in all of my terms, so there's no GCF, right? So I'm just going to move on to step 2. Step 2 requires me to do the modified x method, and this is where your AC really comes from, right? So your AC comes from multiplying your a times c together, right? So first, determine what your a, b, and c are, right? So your a is going to be 2, your b is going to be 7, and your c is going to be 3, right? We want to multiply a and c together. So when we multiply a and c together, we get 6, and that's why I put that at the top. And then we still place b at the bottom, right? Just place b at the bottom, right over here, right? Same kind of thought processes. The same kind of thought process goes for when we're doing our x method now, right? So you want to just find a factor pair of 6 that adds up to 7, right? When I think about my factor pairs of 6 that add up to 7, I think of 1 and 6. So let me just highlight that. 1 and 6, right? Because 1 times 6 is 6. 1 plus 6 is 7. So looks like I did that correctly. And I want to just rewrite my middle term in this case 7x, as my factor pair, right? So I'm going to keep this term, this 2x squared, and this constant term the same, right? And the only thing that changes is instead of writing 7x, I'm going to write 6x and 1x. Now what I want to do is just factor by grouping, right? So I create my first group as 2x squared plus 6x, and my second group as 1x plus 3. And when I'm factoring by grouping, I take my groups and actually just take out the GCF. So over here in my first group, 2x squared plus 6x, my GCF is 2x. In my second group, I don't have a GCF, right, other than 1, so I'm just going to write out 1 on the outside. I see that I have this common group, x plus 3, so I write that out in a separate group of parentheses. And whatever's left over, right, in this case, my 2x and my plus 1, I'm going to write out in a second group of parentheses. And so this is going to be my fully factored expression. So it's not too different from the x method, right? The only difference is that instead of using this method to directly factor and find your factor pairs, right, you're using this to just rewrite your middle term. Let's try this out, right? Once again, this is a check for understanding. This will work out, right? So it's not going to be a fake out like the last check for understanding. So take a minute to pause here, see if you're really getting it. Use the steps that I provided just to kind of guide your thinking. All right, you worked through the problem. Let's go through it together to make sure that we did it correctly, right? So my problem is 2x squared minus 13x plus 20. First things first, I want to check to see if there's a GCF, right? For my GCF, I want to see whether or not there's a number that goes into both 2, negative 13, and 20. That's not 1, right? And the only number that goes into all three of those values is 1, so there's no GCF, right? Just going to move on to my next step. I want to do my modified x method, right? So my modified x method makes me determine what my a, b, and c are. So my a, in this case, is going to be, let's see, my a is going to be 2, my b is going to be negative 13, and my c is going to be 20, right? What I put at the top is multiplying 2 and 20 together, right? So 2 times 20 gives me 40. So my AC is going to be 40. So I want to multiply it to 40. And I want to add up to this b value, negative 13, over here. Right, so now I want to actually do my x method. When I think about a factor pair of 40, right, I want to think about like 1 and 40, 2 and 20, 4 and 10, 5 and 8, right? The only one of these that will add up to 13 is going to be 5 and 8, right? That being said, our b is negative 13, and I know that a negative times a negative is going to give me a positive, so I'm going to change all these factor pairs to negative, right? And then finally, I know that negative 5 plus negative 18 is negative 13, right? So I found my factor pair. I'm just going to write that out. So I have negative 5, negative 8. Okay, so I can move on to step 3 now that I found my factor pair, right? I'm going to rewrite my middle term. In this case, that's negative 13x using my factor pair that I found, right? So instead of writing negative 13x, I'm going to write 2x squared minus 5x minus 8x. Now I want to factor the expression by grouping, right? So let's pick blue for my first group. So this is, this is going to be my first group that I'm going to factor out my GCF. When I look at 2x squared minus 5x, right, my GCF is going to just be x. I'm going to write this in opaque. My GCF is just going to be x, right? When I divide out an x here and an x here, I end up getting 2x minus 5. In my second grouping, let's say that this is green, right? My second grouping, I'm seeing that my GCF is going to be probably negative 4, right? I'm going to make it negative 4 just so I can have a same group by the time I'm done with this, right? So when I take out my negative 4, right? Negative 8x divided by negative 4 is 2x. 20 divided by negative 4 is minus 5. lo and behold, I have a common group, right? My common group I'm seeing is 2x minus 5, 2x minus 5. So let me just write that out. This is 2x minus 5. And whatever's left, right? So let's say that whatever's left is this value, x and minus 4. I'm going to write it out in a separate parentheses, x minus 4. And then that is my final answer. So this one is pretty hard. It's a little bit more involved. And remember, it does require every single factoring skill above it. So if you're not solid with GCF, go back to GCF. So if you're not solid with step 1, go back, right? If you're not solid with factoring by grouping, meaning step 4, right? Go back to factoring by grouping. If you're not solid with the X method, which is step 2, right? Go back to example 3 where we talked about the X method, okay? So before we move on to our last method, we want to go over just one more thing, right? So sometimes when we have quadratic expressions that only consist of 2 terms, meaning our A term and our C term, and if they're being subtracted, so like an example, this would be something like 9x squared minus 1, right? So we have our x squared term and our constant term, right? There's actually something really special going on with our A and C here, and they're called perfect squares, right? So this is a key vocab term that is really, really important to know, right? This isn't just going to show up now in Algebra 1, it's going to show up in Algebra 2. If you take the SAT, it's going to show up there. If you take the task exam in the future, it's going to show up there, right? So you want to make sure that you know what a perfect square is. And a perfect square is an integer, so it's a positive whole number that can be written as some number times itself, right? So let's look at something like 9, right? So 9 is a perfect square because you take some number, like 3, when you multiply it by itself, 3, right, you get 9. Right, so 3 times 3 is 9, so 9 is a perfect square. I would say, like, you know, you can just know the definition for a perfect square to just help guide you to see what numbers could be perfect squares. But something that might just help is, in order to recognize when you have a perfect square, I really recommend memorizing or familiarizing yourself with the cheat sheet on the next page that I'm providing. So let's move on to the next page. So on the next page, on page 14, right, you have a cheat sheet called Perfect Squares cheat sheet, right? And all the values that are in the red box, right, these are all perfect squares. So whenever you see these numbers, you want to think, oh, that's a perfect square. I can do difference of perfect squares, or I can do perfect square factoring, right? This actually goes to show, like, why this is a perfect square, right? So like something like square root of 4 is 2 because 2 squared, or 2 times 2, some number by itself equals 4, right? So just really memorize those numbers that are in that red box to help you identify very quickly when you have a perfect square or when you don't. Okay, let's go over an example, right? So I want to go over difference of squares factoring. This is our final method. If you're really solid with the previous methods, this should really just be a piece of cake, right? So the first thing that you want to do is just determine what your A and C are and if they're perfect squares, right? So let's look at this. My A over here is going to be, let me color this in red, right? My A is 4, my C is -1, right? Or just 1. And I know that because my A is 4, which is a perfect square based on my cheat sheet, right? I know that maybe I can move on. So I want to just check on to see if C is a perfect square. C is 1, which is also a perfect square, right? So that means that I can actually do my difference of squares factoring. Okay, so when I do my difference of squares factoring, I want to follow this basic skeleton or this basic structure to help me with it. And I know it looks really complicated, but let's just look through it, right? So I want to do the square root of A times X, right? And my A is 4. I know the square root of 4 is 2, right? So this is going to be 2x. And I want to do plus square root of C. And when I do square root of 1, square root of C, that's just 1. So I'm just going to place a 1 there. It looks exactly the same in the next group. The only difference is you change that plus sign to a minus sign, right? So you should end up with 2x plus 1 times 2x minus 1. It should look exactly the same. The only difference is just going to be that positive gets changed to a negative, okay? So whenever you're factoring, please make sure to see if there's a GCF before getting started with any other method. I saw that the GCF was just 1 for this, so I didn't even bother taking out the GCF, right? But in other problems, it might be helpful, right? Because you want to be dealing with as small of a number as you can because it's going to be a lot easier to manage. So, final check for understanding, okay? Pause here, right? Make sure that you're going over your example from the previous page to really check to see whether or not you're getting what this concept is going for, right? And then try out this example. Remember to factor out any GCF that you might have, right? So I actually gave you a hint that you do have a GCF in this case. So determine what that is, right? And then move on to your difference of squares factoring, where your a is going to equal 1. All right, you tried out the problem? Let's go over it together, right? So your problem is 2x squared minus 162. I gave you this hint, right? There is a GCF, right? When I'm looking at this, right, I see that 2 does go into negative 162, right? So because 2 does go into 162, my GCF is going to be 2. All right, let me just write that like that. Okay, so now that I've taken out my GCF, this x squared minus 81 is going to be what I'm going to do the difference of squares factoring on, right? So let's look at my step 1, right? I want to determine whether my a and c are perfect squares, and then I want to take the square root of a and c if they are perfect squares, right? So my a is 1, as I said, because the coefficient for 1x squared is just 1, right? And I know that 1 is a perfect square, right? And the square root of 1 is 1, right? So I'm going to use that piece of information later. My c in this case is 81, right? My c is 81, which is a perfect square, because I know that 9 times 9 is 81, and so the square root of 81 is 9. Okay? So now that I've done that, I just want to follow the skeleton for my difference of squares factoring. So first things first, I'm going to put my GCF outside so I don't forget about it, and my GCF in this case was 2, so I'm going to write that outside here. Now I'm going to follow this basic skeleton, right? So the square root of a, the square root of a was 1, so I'm going to write 1x, right? Plus the square root of c, my square root of c was 9, so I'm going to write 9 here. Same kind of thing, I should be writing out the same expression. The only thing that changes is this minus sign right over here. Right? So I'm just going to put everything else as the same. 1x minus 9. And that's going to be my fully factored expression. Okay? If you're struggling with this, right, check to see what skills are really a little bit troubling for you, right? So if it's actually determining what a perfect square is, right, then make sure that you're figuring that out. If it's the GCF factoring, then go back to example 1 to help out with that, right? But you want to just make sure that you're covering and being specific about the skills that you really need to work on, right? So this is the last example of all the different kinds of methods that we've been covering for factoring, right? If you have any questions, please reference the specific check for understanding topic or the specific example, and try to figure out at what step you're really struggling at. If it's, just getting started, that's fine, but please be specific about the type of example that you want me to cover with you. All right, good luck.